Good morning, friends. Today we are going to discuss about COBOL. COBOL is an acronym for Common Business Oriented Language. It was developed in the year 1959 based on the recommendations of a group called CODECIL, which is Conference on Data Systems Language. The first COBOL compiler was introduced in the year somewhere around 1968, and the modified ANSI approved version was introduced in 1974, which is also known as OSVS COBOL or COBOL 1 or COBOL 74. And again in the year 1985, COBOL 85 or VS COBOL 80, COBOL 2 was released. Okay, and our discussions will be mainly based on VS COBOL 2 as an example for our forthcoming slides and examples which I'm going to go on mainframe. Okay, now what are the features of COBOL? COBOL is a structured procedure oriented language. That is, the emphasis is given on the procedure, that is on the task, unlike your C or C++ where it's C++ or Java where the emphasis is given on the objects. Here or rather the data. Here the emphasis is given on the procedure or the task. COBOL is very simple to understand. That is why it is it's like an English-like language. COBOL is primarily used for business purposes, all the banking application, many of the insurance application, healthcare and retail. All the big companies, big MNCs use COBOL as their backend programming language and the mainframes. Now this is the COBOL compilation process. What do you mean by source code? Source code is what you are going to code. What is the COBOL program what you are going to code? It is fed to a compiler known as IGY-CRCTL, which generates an object code, and then it's link edited and a load module is obtained. You need a load module to execute a program which is understandable by the mainframe or the machine. Okay, now this is how you're going to code a COBOL program. You are going to leave 1 to 6 column numbers as it is, because this will be auto populated. I'll show you how to auto populate 1 to 6 column numbers, and 7 is generally left blank. Unless you want to comment a line, then we put something on a star or slash or hyphen. I'll come to slash and hyphen at a later stage. 8 to 11 is area A, where we are going to code our division names, paragraph names, and other division names, paragraph names, section names. Whatever is not covered in area A is covered in area B. That comes between 12 to 72. And so whatever you code between 73 to 80, the compiler ignores it. Just as we discussed, star is for commenting a line in column 7. If you add a slash, it is like equivalent to commenting a line but putting a page break along with it in the compile listing. And slash is for continuation. Suppose you want to continue a command from one line to another line, you put continuation as hyphen in the column 7. Now this is how a structure of COBOL. Let me start from 8 to 1. It's easier to understand, and then I'll tell you why it's. See, in English, the smallest thing what you can think of is a character. That is A, B, C, things like that. A group of characters make a word. For example, reserve, receive, send, all these are words because it has a space before and after the group of characters. A group of words is a clause, like I am going to. You can just make it as a clause. It itself has got a meaning, but it's not a statement as such. Statement is basically one line of COBOL code. You can call it as a statement, and a sentence can be a single line or a group of statements which ends with a dot. Dot is known as an implicit scope terminator. The period operator, which is nothing but a dot, is known as an implicit scope. A group of sentence or a single sentence can be put in a paragraph, and a group of paragraphs constitutes a section, and a group of sections constitutes a division. Like if you see the first three, division, sections and paragraphs, must begin in area A or margin A, whatever you want to call it, Rest of the statements automatically fall in area B. Okay, this is mandatory. As already discussed, all divisions must start with area A, that is between 8 to 11, and there are 4 divisions in a COBOL program, that is identification division, environment division, data division, and procedure division. Okay, these are the 4 divisions, out of which identification division is the only mandatory division in your COBOL program. Although your program has all the other divisions as well, but identification division is the only mandatory division amongst all the other divisions. So what does identification do? It identifies the start of the program, the name of the program, who has written it, when was it installed, when was it written, when was it compiled, security, whether it's confidential or non-confidential kind of things. Okay, there is no section under identification division. We don't have a section under identification division. Under identification division, if you see whatever is written in caps lock on, that is basically because COBOL, when we code, we usually put caps lock on, that is caps on as the ISPF profile, and whatever is given in greater than less than symbol is what you are going to code. That is the name of the program. Author can be your name, or if you want to have a generic name, then you can keep your user ID as well. Installation, where was it installed, date written, when was the code written, date compiled, when was it compiled, security, as I already told you, whether it's confidential, non-confidential, public, anything, you can write anything there. Okay, of all these 6 paragraphs under identification section, only program ID is mandatory. That is, it identifies the program name. The rest of the things you can skip while coding your first program. But if your installation, let's say in your MNC or the corporate where you work, they have given this, you can simply copy paste and modify accordingly. Author, you can change it to your name. Installation, you can keep it as it is. Date written, you can change when you have written the code and when you have compiled it. Security, likewise, if they have coded, you can just copy paste that. But program ID is the one you need to change. Okay, so we have understood that for an error-free compilation, minimum requirements are identification division and program ID. Now, the next is the environment division. Environment division provides the information of the computer and the peripheral devices where we are going to compile and execute these programs. Again, there are many sections and paragraphs under environment division. We'll see the different sections and paragraphs. Configuration section. Configuration section basically has source computer, name of the source CPU, where you have written the program, object computer, where you are going to execute, where you have compiled your program, written your compiled your program becomes your source computer. Object computer is where you are going to execute the program. Generally, these two are going to be the same names. Special names is a special reserved word. Typically, when you want to replace a symbol with some other word kind of thing, we use special names. For the time being, we'll just park it here. Next, we come to input output section, where we have the file control. File control basically has all the file related information, if at all we are going to use the files. Again, we'll be seeing this in the later part of the sections. Then we have IO section. IO section basically has whether what kind of storage and things that you are going to use. That is what comes under IO section. Whether you are going to use the same storage for different files, then we will specify these kind of things in the IO section. Okay. For example, the special names they have already given: specify quadratic sequence or specify currency sign substitution. Next, we have the data division. Remember, all these should come in one order. First, you will have to code an identification division, then environment division, then followed by data division, then finally, where we'll come to procedure division later on. Finally, we code the procedure division. In data division, we are going to just discuss the 3 which are highlighted in red, which are nothing but file section, working storage section, and linkage section. File section is used to declare the file variables. Working storage is used to declare the variables which are used in the program. That is, whatever is local to the program, we are going to declare it in the working storage section. Linkage section is used to declare variables used to pass data from another program. Suppose you want to call another program, then linkage section comes into picture. Suppose you want to pass a program to a JCL which is external to the program, then also linkage section comes into picture. Hope things are clear. Procedure. Finally, procedure division. All the business logic is written in this division. There is no system defined section here. All these paragraph names, whatever we are going to code in procedure division, are user defined names that is used for our understanding, and whatever makes it more readable, we are going to do the indentation and documentation as well in the procedure division. Now, three kinds of data what we are going to define in COBOL. One is variables, the other one is literals, which are nothing but constants, which are not going to change during the compile time or runtime. Figurative constant, which is nothing but instead of we'll come to it later when we are discussing instead of 0 I can use the word zero. Likewise, instead of spaces actually hard coding spaces as single quotes, I can use SPAC. Okay. Now, first one, variable. It's a name memory location which holds data. For example, first name, phone number, these are all variable names. So variable names is pretty simple. You will just have to follow these naming conventions. It can variable name generally we give any variable name can hold maximum. If you're having a numeric data, it can hold up to 18 digits, and if you're having characters, it can hold up to 160 characters. That is in COBOL VS COBOL 2. In VS COBOL 1 it was only 120 characters. And literal is nothing but a constant, anything which is not going to change its value during runtime. Wherever we are going to assign a value, for example 10, Arun is put in single quotes, which is nothing but a character constant. And likewise 24/7 not is a character constant. Figurative constant, instead of coding the value digit 0, I can use 0 or zeros, space or space, likewise quote or quotes. This makes it more readable, program more readable. That's why we use figurative constants. Two types of scope terminator. One is the implicit scope terminator, other is an explicit scope terminator. Implicit, as the name understood, it is understood that it is terminating the scope. So dot is used as a implicit scope terminator. That is, whenever if I'm having a if clause and I don't code an end if and I just put a dot, that dot will act as an end if there. So that is nothing but an implicit scope terminator. Whereas an explicit scope terminator, we explicitly specify what is the scope terminator. This explicit scope terminator was introduced in COBOL 2, not in COBOL 1. In COBOL 1 it was not there, but in COBOL 2 it was introduced. So how do you code an explicit scope terminator? If you have an if, then you code end if. If you have an evaluate, then you code end evaluate. If you have a perform statement, then you code end perform. So basically we add the end keyword for whatever operations we are going to perform. That is nothing but an explicit scope terminator. Now this is a very important slide. This is how we are going to declare a variable. If you see, every variable starts with a level number. Now the level number, if you see 01 to 49, 77, 66 and 88, these are the different level numbers available to us. Okay, 01 to now 49 is we mostly use in our program, used for group elements or individual data items. 77 is used for independent data items or independent elementary items. 66 is used for rename variables. However, now in most of the code, these 66 level has become obsolete. 88 is used for condition variables. Okay. Now, for example, if you will look at a next slide, or we'll go to an actual code to see how data is declared, that will give you more clarity of how to code, this one. If you see the first line, there are many things which I'm not going to cover immediately, because as and when we go through the slides, then you will understand it. So basically we will cover the level number, variable name and picture clause. This picture clause is used to identify the data type. There are predominantly three kinds of data types in your COBOL program: alphanumeric, numeric or alphabetic. Again, there are variations where, such as numerically edited kind of things, which we are going to discuss later. But predominantly, these three are the three different data types available for you to work upon. Then value clause is used to assign an initial value to a particular variable. Last time we saw constants, things like 10. If you want to assign a value, then you can assign value 10 or value in quotes vivid. Okay, likewise. Occurs clause is used for arrays, which we are going to discuss later. Usage clause is again we are going to discuss in the later slides, where how are we going to store a data internally in your mainframe. Then the usage clause also comes into picture. How do we want to use it? And the finally is the sync clause, which is used to establish better addressability. That is when you want to computer reads addresses quickly if they're evenly divisible by 4, 2, 8, some kind of things like that. Okay. As we discussed, it is a variable name is just a name which points to the memory location where a value or data resides. It consists of both alphabetic, numeric, and hyphen. Remember, hyphen, it's hyphen, not underscore. Underscore is not a valid this one. Your variable name should start with alphabet or something known as national characters. So what are national characters? At the rate, dollar, and hash are known as national characters. Again, I repeat, at the rate, dollar, and hash are known as national characters. Variable should not end with a hyphen. If you see, there are some incorrect this one in the first one is starting with a hyphen, the second one is starting with a numeric. It should always start with an alphabet, as I told you, and the last one is ending with a hyphen. So all these three is this one will be considered as illegal variable names in your COBOL program. Now, picture clause, as I already discussed, it describes the attribute of the data used to specify the type and length of the variable. These are typically the values which numeric data can hold: 100, 45.234, minus 534.00. Text is nothing but alphanumeric data like Arun, anything put in single quotes, Arun, mainframe, mar123@atra.com.au. Okay. In COBOL, there are 5 basic data types, which is nothing but 9. 9 stands for numeric, S stands for assigned, this one. See, if you see, although we discussed only 3 basic things, S is basically assigned integer, 9 is an unsigned integer. Okay, it comes only along with numeric. S and V comes along with numeric, so that's the reason I clubbed all 3 and put it as a single this one. Fourth one is alphabetic, fifth one is alphanumeric, which can hold both numeric and alphabetic data. V is a assumed or a implied decimal. It does not occupy any space, but it is understood that decimal comes at this point. And 9, when I give, it's assumed that it's an unsigned integer, that is, you don't hold the sign. For example, when we are writing 123, it's understood that it's a positive number. We are going to not going to store the sign. We cannot hold negative values where signed this one are there in the numeric bit. If you see the first example, phone number, pick 9 of 10. What it's telling is the name of the variable is phone number, which is declared as an independent variable under 01 level. The picture clause is identifying the data type. It's telling that it's a numeric data because it's starting with 9, and it takes 10 bytes. That is why you give 9 of 10. I can either give 9 of 10 or 9999999, 10 times 9 if you give, that also works fine for you. Okay. Likewise, the second one, if you see, 9 of 6 V99. Remember, there is a dot after every 01 level, this one, because every variable is a separate sentence. Okay. Now the second variable is basic pay, which is 9 of 6 V99. Here it tells that there are 6 places in the significant byte, and there are 2 things in the decimal part. So the something like 12345.6.78. Okay, the dot will not occupy a space because V is nothing but an implied decimal. Likewise, if you see a final value, this is also a numerical value, S999V99. Basically, it occupies 5 bytes. If you see 999 P99, sign also doesn't occupy a separate storage. This one, it is sign is over punched on the last byte. Okay, So basically it occupies 3 digits for your most significant byte, and the next is the decimal point. There are 2 digits after the decimal point. Then you have first name, which is an alphabetic this one of length 10. Okay, that means you can store maximum of 10 bytes of alphabetic data. Then comes the email ID, which is nothing but alphanumeric, where both numbers and alphabets can be stored in quotes with a data of length 40. Okay. Now, we talked about the basic data declaration. These are numerically edited or not numerically edited. Basically, editing any picture clauses. Typically, editing picture clauses is done for output variables. These are typically used for your input variables, where 9 of 10 occupies 9 of 10 only. But in output, when we want to display in a different format, then we use this edited picture clause. For example, B. Suppose if I have xb something like that, then whatever you are going to move, that b will move a blank there. For example, if I move cat to another variable which is xb, then cat will be c space a space t, something like that. Okay, now if you see, instead of v, if I give a dot, that means it is actually physically holding a byte for the decimal now. So typically when we implied decimal is for our understanding, but when we want to display the variable, we want it to be explicitly showing the decimal point, in order to not to confuse the programmer, what the end user, whoever is seeing it. So for output variables, generally we put the decimal. Likewise, a dollar symbol is a currency symbol when we want to add a dollar in front of the final result, as just now we have rupee for our Indian currency. Likewise, when you want to have a dollar in front of your final total kind of thing, then you can add dollar. Likewise, asterisk is used for your all your printing, this one, where we want to have asterisk as a this one editing character, we can use asterisk as well. Comma, for example, 5 lakh, you want to display as 5 comma 00 comma 0000, then we use numerically edited clause comma. Plus or minus symbol, when we want to explicitly put plus or minus in front of a numeric digit, especially in accounting and financial, this holds a lot of significance. Plus or minus putting in front of a numerically edited data item. Then zero suppression. For example, when you are displaying pick 9 of 5 whose value is 123, it will display as 00123, because why? It is occupying 5 bytes, so it will pad zeros in front of the remaining digits, this one. So the value doesn't change, only thing is while displaying it will show as 00123. Supposing you don't want that 00123, you just want it as 123, then you will have to add the zero suppression as your you have to code z. Then instead of pick 9 of 5, you can code z of 5, then it will suppress all the zeros, leading zeros. Likewise, you can have zero suppression after the decimal point as well. Next, you have the slash. Typically you use it for your date operations and things like that, when you want to have a slash appropriately. And finally, the letter 0, we had already discussed about figurative constant. Instead of 0, we can actually code the keyword as 0. Okay, it makes it more readable. Now value clause, as we already discussed, when we have a pick clause and we want to initialize that variable with a particular constant or a value, then we use the value clause. Typically 1 2 3 4 5 6 minus 428.00, these are all what we are going to assign to a particular variable, which can be numeric. The first two are first one is numeric, second one is signed numeric with a decimal. The third one is a character, this one generally you can keep it as alphabetic. On the fourth one, we'll keep it as if you are having any by chance any number, then you can keep it as alphanumeric. We'll the usage clause I'll skip for the time being. We will just see an example of how to this one. Let's see an example. Okay. this is your main screen. Firstly, you'll have to enter your mainframe credentials. Okay. We have logging in to the main screen. Now this is how your ISPF main screen looks like. Now before you code a COBOL program, you will have to code a PDS where you are going to code all your COBOL programs. If you see here, there is no dataset called COBOL.sourceLib. So what I'll do, I'll take already existing one so that I can model it accordingly. Go to 3.2, allocate a, take an existing one, so don't allocate now. Go to this one, dataset name, give already existing datasets whom you want to model. See, if you see here, it is a partitioned dataset, okay, and it's a fixed block, this one, a record length of 80 and 800, and likewise you will give the directory blocks and tracks allocated to it. So now it takes the model, this one. Now you give tekken36.cobol.sourceLib. This is what I am naming my PDS. So now it will take the attributes of the previously whatever we had entered. Just press enter. Now this PDS is created. Now what I'll do, I'll go to 3.4. I'll go to COBOL.sourceLib. Now the first time when you are creating a data program or a member, remember you cannot directly edit to this one, so you will create as prog 001. This is my first program, okay. Press enter. Now let's do one thing, let's put calls so that now you know how we have to enter the data. If you see here, I am coming here to after 6th, 7th also I am leaving. Now here is where I am coding my identification division. Okay. Now I'll do a num on call. Remember, when you want the sequence number, as I told you, when you want the sequence number to be automatically generated, you'll have to give num on call. Now if you see the number is generated, I'll do a shift F11 just to show you. See, this is this one. Now again you want your COBOL code to be highlighted, so I'll do a high call. If you see here, all your COBOL code will get automatically highlighted if you do a high COBOL. High COBOL is nothing but highlight COBOL, okay. Next, what was the next thing what I told you was program ID. Program ID, I'll give the name as the same thing, prog 001, okay. Now this becomes your program ID. If you see here, program ID is a keyword and prog 001 is a nothing but it's your program name, okay. Now since there will already be some coded this one, I'll just pick up something and then to make things faster. Okay. Just 1 second. Sorry. I've cut some lines of code already coded because I don't have to. See, if you see the additional lines have come, how do you remove it? You can use the ISPF line commands shifted by 6 bytes. Now you have environment division. Again, you want to shift this by 1 byte. What do? You just do the closing bracket and just one do. So this is basically used for your indentation. If you see, the level number also comes as the same way, same this one where divisions and sections are coded. Now we are just going to have our working storage section with the variables. We are not going to have anything in environment division, source computer, object computer. Like I told you, you can model it on your existing program, whatever we have coded in your installation. Let's say we don't want this also. Just let's put it on num1 pick 9 of 03. Okay, value 1 2 3. Now I'm assigning a initial value of 1 2 3 to num1. Likewise, I will have an alphabetic this one also, alpha pick x of 03 value all star. I can have I have not yet come to the I have not discussed the keyword all. When you want, instead of coding something like this, this is the same as coding hope it's clear. So typically when the size becomes larger, this all plays a very handy role. For example, now if I put 23, instead of coding 23 times the star, I can give value all star, so it will be automatically put in 23 lines, 23 columns. Sorry, not lines. Okay, so we have just taken simple examples. Now once data division comes, then we will discuss something known as procedure division. As I told you, procedure division is the place where we are going to code all our business logic. So now we don't have any business logic as such now here. I am just going to show you one simple this one. So now what I am going to do is I have initialized the variables and I just want to display it in your output. For example, normally when you do this one, you will be inclined to see hello world, right? So let's just do hello world, pick x of value. I'll just count how much. Hello is 5 6, then world is again 5, so 11. So just have it as 11. Okay, here in the procedure division I will just display whatever is written in this. So display is basically if you give in quotes, for example, if I quote something like this, that means whatever value is there in num1 that gets displayed. So however I want to display certain things, for example, num1 ws num1. Okay, just there is a space after it. So now if you code like this, now here num1 will be displayed, and after that you will also have what you call the values of what is stored in ws num1 will be displayed. Let me just okay, so now we are displaying the first variable. Now next variable I want to display as alpha. Okay, so you will have to give the same name, alpha. Thirdly, I want to declare the show the variable hello world, so I'll just give hello world ws hello world. If you see, these are the variable names. ws num1 is coded here and here, ws alpha is coded here and here, and hello world, whatever variable we are going to use, coded here and there. Finally, once we have all these things, we have to make an exit. For that we have a special keyword known as stop run. Stop run marks the end of the program, so we have to tell that give the control back to the OS and do a stop run. So we'll save it. Now this is your first program. Okay, we are just displaying whatever we have initialized with the value clause. We are just going to display it. So we'll come out of it. Automatically it is saved. If I come to my job lib, I'll have to compile the program. See, I told you there is a proc here. Again, I'm going to highlight the JCL to identify. This is a proc which executes two programs known as IGYCRCTL and IEWL. One is called the compilation, this one which creates the object module, and from the object module this creates the load module. Okay, so let's just change it to Tekken 36 wherever this one is there. And now I have to create a load module. So what I'll do, I'll model it again because load module is not there. So we just go to 3.2. So created a load module. So I'll change it appropriately. Okay. Now what is the program that I am going to compile? So what was it? Proc 001. If you are not sure, again go to Tekken 36.cobol.src. Okay, here I am going to pass a symbolic variable, so which is nothing but the proc 001 if you see here. Okay, let's just wait for this one. Let me just verify everything. Let's again go to our program just to cross verify that it's remember, whenever you are after you code, you have to come out of edit mode. Some people, when they after they code, they don't come out of this one. If you see F10, okay, proc 001, we generally keep the same name as the member name and the program ID will be generally same. So now let's just submit it. Give him maxcc8. Let's see what is the reason. See, there is one error what it's telling. A period was assumed before the procedure division. Yes, we missed a period after procedure division. Okay, before the okay, let's go back to our program now. Now this is this one. There's dot is a very important this one. Please remember, if you miss a dot, you'll get a lot of errors. But it will go, and it's sometimes very difficult to debug if you have missed many dots. So a good practice to always end this one. See here he says before procedure division I am not given a dot. So here there is a dot missing. So I give a dot. Automatically when you press F3 it is automatically saved. What I do again, I go now, instead of coming back to the this one job, I can do an SJ in SDSF. Again I can do a high JCL to highlight the JCL statement. I'll again submit it. Now it gave a maxcc 0. If you see there on the top, maxcc is 0. Okay, so it will show you. See, both the COBOL compilation and link edit step has gone fine. So we'll just see the final this one where it is going. Shift F8. If you see the finally the load module, yes, so this is my load module. So once you compile it, you want to just check where the load module is. You just code like this, you browse it. This is the load module. It will not be user readable. It's what is written in object code. Okay. Now this is a very important thing for us to run this one. So let's go to Tekken 36 job lib where we are going to run the program. Let's just go to cob run. Now I I will come in edit mode because I'll have to change a lot of things here. I will change it to my user ID, which is taken36. Program name was prog001, prog001. Okay, this was my load module. So I give taken the disk because I can give it a share also, not a problem. Sysint DD dummy. Now remember, we have to use sysout because display by default routes it to sysout. So I'm sure you are aware of all sysout, sysprint, and other important JCL DD system provided DD statements. So here we are going to specify this is the job card, this is the program I'm going to execute. Since it has no input and output, I have to just specify the load module where this program is residing, that is present in steplib what I'm going to do. Finally, sysout. Sysin also is not required. I can delete these two lines. Likewise, I can delete the sysprint line. So I'll just submit this job. Let's see what will come. If you see, it got a max is 0. So we'll just again go to the spool. So this was the job which I ran, and I told you the output comes in run. If you see here, num1 I have 123 is what I've coded. Alpha basically has 23 stars, and hello world, the value what is stored in hello world is displayed. These are all the values. If you compare back your program, these are the values whatever are stored inside these variables. This is whatever is in quotes is displayed as is. Whatever is not in quotes is displayed along with the whatever initial value you have assigned it. In case you have not assigned any initial value, it can have garbage values or non-displayable characters as well. Okay, so that's our first COBOL program, and we'll just stop here.